So we're on 4.6. We're talking about isosceles, equilateral, and right triangles. We have talked about this before. We're just going a little bit more in depth. Base angles are two angles that contain the base of any isosceles triangle. And remember the other day we talked about isosceles triangle? An isosceles has at least two sides that are congruent. And the base angles are the angles that connect the legs of the isosceles triangle with the base. The base angles on an isosceles triangle will always be congruent. They're always going to be the same measurement. The vertex angle on an isosceles triangle is the side that is not congruent. It's the angle, excuse me, not the side, it's the angle that is not congruent. Okay. It connects the two legs of the isosceles triangle. Okay, now the theorem below just restates what I've said. The base angles are going to be congruent. So angle B, and what other angle is going to be the same? And angle C. Even though the base is not on the bottom, it doesn't matter. It's the base is the side that's not congruent. All right, some parts of the isosceles triangle, we've talked about them before. The legs are those congruent sides. The base, of course, is the side that's not congruent. Base angles, vertex angle. Just a nice little picture to use. All right, the converse of the base angle theorem says this. If you have two angles that are the same, the sides opposite of them are congruent. So what side is going to be congruent? Not B and C are angles or points. So it would be the segment, this AC and AB. Okay, AB is congruent with the segment AC. All right, so the corollary says this. If a triangle is equilateral, then it is equal angular. I told you that before. If all the sides are equal, then you know all the angles are equal. And all the angles will be how many degrees? 180 divided by 3, which is 60. All right, works backwards. If it's equal angular, if all the angles are equal, then you know automatically all the sides are equal. Okay, equal angular has the word kind of angle in it. Equilateral has the word lateral, which means line. So that's something you need to know. The value of y. All right, well, here's the deal. I've got this picture, and it's really two triangles. Well, this triangle is an isosceles triangle, right? Everybody agree? Yeah. And then this triangle over here is an isosceles triangle. Because you got two congruent marks here. What do I know about this piece right here?
That will equal 180.
Good. That is a straight line. It's going to equal 180. So 180 minus 70, okay, that equals this angle right here, okay? So 180 minus 70 is 110 degrees, right? Good. We know that. It's 110 degrees. Now that I know one angle in an isosceles triangle, what do I know about the base angles? They're what? They're congruent. So this angle and y are the same. So it means that they're both exactly the same. So I could do it backwards. I could do 180 minus 110, which is going to, of course, give me 70. So these two angles together are 70. Okay, so I have two angles added together to the same amount. Let's call them y, since that's good. That's all you do. You got two angles that are the same. They're both y, and they're going to equal 70. So he says take 70 and divide by 2. And you get 35 degrees. Okay, it's a long way around it. You can always remember this, guys. These two angles, right here and here, are going to equal the exterior angle. That's another theorem we talked about before, right? So you didn't even have to do this first step if you didn't want to. Remember, the two interior angles are going to add up to equal the exterior angle. Saves you some time on the ACT if you have that problem. All right, this is an isosceles triangle. Okay, what do we know about all three angles? They add up to be what? 180. So I know that 75 plus 5x plus 3y equals 180. The problem is I have what? I have two variables, right? And right now I can't solve for two variables. But can I solve for one of them?
Yeah.
Which one?
Solve for
5. Why?
I meant 5x.
Okay, she says I can solve for the side with the 5x, and she's right. I have to solve for x first. Why? How do I know to do that one? What do I know about 75 and 5x? They're the same because they're the base angles, right? So I know that if they're the same, I can set them equal to each other and solve. So 75 divided by 5 is 15. So x is 15. And over here, I know that I have 75. Well, of course, this is going to be 75 too, right? Because they're going to be equal. Plus 3y equals 180. Okay. And I can add those together, and that, of course, is 150 plus 3y equals 180. Subtract by 150 to both sides. And do what? Divide by 3. So y equals 10. So I've got my x and my y. That wasn't too bad. Now this one takes a little bit more because it's more involved. All right, so we have quite a few triangles going on there. Do you see them? You see the three different ones joined together? What do we know about this middle one? It's an equilateral, and if it's an equilateral, it's also a equal angular. And equal angulars have what degree of an angle? 60. So you know this is 60, 60, 60. Okay. Good. Now I can find x or y, your choice of which one you want to go next. What do we know about isosceles triangles? Isosceles triangles, what do we know? The angles, all of them, any triangle, all the angles add up to equal 180. What else do I know specifically? The base angles are what? The base angles are congruent. So this angle and this angle are both 70. So can I find x? Right, because you told me that they all add up to be 180, and I have 70 plus x plus another 70 because the angles, base angles, have to be the same. So I've got 180 equals 140 plus x. Subtract 140, I get 40 equals x. So I've got my x. Now you got to look at it and see what else you know. How do I even start on the next one? What kind of triangle is this next one? It's isosceles, so we know that base angles are equal. Where's my base angle? Y and this one right here, right? Right. So it's really saying that I have a y and another y. How do I find this measurement? Okay, somebody said guess, and that's probably not the best concept there. Okay. So add 70 and 60. You can do that. Now what would you do with it once you added them? Are they equal? Oh, good. She saw that there was a straight line right here, and that means that they all add up to be 180. So she has 60 plus 70 plus whatever this other angle is. I'm going to call it angle P. I don't have a clue. Equals, you can put question mark, whatever. That's because what she said. So 130 plus P equals 180. Subtract from 130, so that new angle that we talked about is P, and you get P equals 50. So P is 50, right? Okay. And we know the other two angles are the same. And again, this is not the only way you could have done it. You could have done 130 divided by 2. This is what's going to happen. 180 minus 130, or excuse me, minus the 50. Because all three triangles add up to be 180. You're going to get what 60 and 70 added up to be. And there's two different ways to do it. I don't care which way you do it. You get 130. Now, we know that we have two y's left over, right? Because they're base angles. And they have to add up to equal 130. Divide by 2. And you get 65. Now, you said this is massive, and that's a lot of work. But remember, do you remember the theorem we talked about a long time ago, that the exterior angle, so this would be the exterior angle of this triangle right here. The exterior angle adds up to equal the two interior angles. So you could have done that at the beginning. I told you you could have. I went by what somebody else told me. So you have 130 equals 2y, what you could have started off with. Okay? It would have saved you some time. But do you see that it worked anyway? You can go through the thought process and you can get there even if you don't remember the theorem. Okay? But that one's a nice one if you remember the theorem. It takes you half the time.